In this section, we'll cover uh, more problem solving. We will get some experience in problem solving where we need to read the question carefully, figure out the details given, and use the given details to answer the question that has been asked. So in this video, I'll cover problems 1 and 2 in the worksheet. In this section, we will do some problem solving. You can take a couple of minutes to read the question. You can pause the video if you need to. So once you've read the question, you'll see that there are two levels of membership. One is a $25 membership, and the other is a $50 membership. Now, we don't know exactly how many level 1 memberships we have, and we do not know how many level 2 memberships we have. However, we know that the total amount in pledges is $350. So this is the equation that you need to pay attention to. So if you think about it, the total number of pledges is 350. How did we get to 350? So there are a certain number of level 1 memberships. We multiply that with 25. That gives us the total of the amount collected in level 1 memberships. We add that to the total amount collected in level 2 memberships. So we multiply $50 with the number of level 2 memberships, and the sum total is $350. So once we get that idea, now we need to figure out the total number of level 1 and level 2 memberships that give us a 350 sum. So we have to consider all possibilities. Now the first row you'll notice that we've considered a possibility where there are only level 1 memberships. So if $350 were collected, the total number of level 1 memberships can only be 14 because 14 times 25 is $350. So we can assume that the number of level 2 memberships is 0. So if we have no level 2 memberships, this last column gives you the sum 25 times 14 plus 50 times 0 equals 350. So that is a possibility. Now, the next possibility is in the second row. So now we have 12 level 1 memberships. So that's 12 times 25. Now, to make up a total sum of 350, we can only have one level 2 membership. So 25 times 12 plus 50 times 1 equals 350, and that's our next possibility. Notice that it is not possible to have anything in between 14 level 1 memberships and 12 level 1 memberships because the level 2 memberships is $50. And if we, for example, had 13 level 1 memberships, then 13 times 25 is the total amount that we get from level 1 memberships, but that leaves us only $25 to make it a total of $350. And $25 is not going to buy us a level 2 membership. So this is not a possibility. That's why we skip from 14 level 1 memberships to 12 level 1 memberships. So the next row gives us the next possibility. Notice that we cannot have 11, and I've just explained the reason why. We cannot have 11 level 1 memberships. So the next possibility can only be 10 level 1 memberships. So 10 times 25 is 250, and that leaves us a balance of $100. And with $100, we can only buy 2 level two memberships. So the total would be 10 times 25 plus 50 times 2 equals 350, and that works out to a total that we need $350. And the pattern continues. Notice that the level 1 memberships reduce by 2 as we go down the rows, and as we go down the third column, you'll notice that the level 2 memberships increase by 1. And each time when we look at the last column, the total amount of money collected in pledges from both level 1 and level 2 um, memberships comes up to $350, and that's what we need. So this table gives us a systematic way to figure out what all the possibilities are. So we can kind of guess what certain possibilities are, but if you go in a systematic way, starting off with 14 level 1 memberships, 0 level 2 memberships, going to the next step, which is 12 level 1 versus 1 level 2, we cannot miss any of the possibilities. So the table, in a very systematic way, gives us the list of all possibilities. Now take a few minutes to read the next question. There are a lot of details given in the question, and make sure you're taking notes as you keep reading the details given in the question. So let's quickly go through this. Karen arrives at the subway station every day, and the important thing to notice is that she arrives at a random time. So basically, she could arrive at any time during the day. Train A takes her to the museum, and train B takes her to the beach. So she either goes to the museum or the beach once she arrives at the station. It all depends on which train arrives first. Now, this is the most important part of the question. A month after starting this game, so let's assume it's about 30 days, she has gone to the beach 25 times and to the museum 5 times. So notice that the time that she arrives favors catching train B, which takes her to the beach, rather than train A that takes her to the museum. So she's more likely to catch train B than she's likely to catch train A, depending on whenever she arrives at some random time. So an important point to note is this. Karen's arrival time takes her to the beach more number of times than it takes her to the museum, which means she's more likely to catch train B than train A, even if her arrival times at the train station are random. So we're given 3 possible explanations of why this could possibly happen, and we'll examine each explanation and see which explanation best explains why she's catching train B more often than she's catching train A. So let's look at that first possibility. So we're looking at possibility 1. Train A arrives on the hour, and the train B arrives 30 minutes later. So let's consider this scenario. Now, obviously, we cannot list every possible hour in the day, so we're just going to take a snapshot of the day, which is about an hour. Let's consider 8:30 to 9:30 time slot. Okay. Now, since the train A arrives on the hour, let's assume that train A arrives at 9 a.m. Now, the explanation says that train B arrives 30 minutes later, so we can assume that train B arrives at 9:30. So we are looking at the time frame from 8:30 to 9:30. Now remember that Karen can arrive any time during the day, and we are only considering 1 hour of the day. So if Karen arrives between 8:30 and 9:30, between 8:30 and 9, then the first train that comes by is train A. So she catches train A and she ends up at the museum. So if Karen arrives any time between 8:30 and 9, she goes to the museum. Now, at 9 o'clock, train A has left the station. What if Karen arrives between 9 and 9:30? The only train that's going to come next is train B. So if she arrives between 9 and 9:30, she takes train B and goes to the beach. So these are the two possibilities in the 1 hour that we are looking at. So if she arrives in the first half hour, she takes train A, goes to the museum. If she arrives in the second half hour, then she takes train B and goes to the beach. Now, out of the 1 hour, we're considering two time slots of equal size, 30 minutes each. Now, we know that Karen's arrival time is random. She is equally likely to arrive in either one of these time slots. There's no reason why she should arrive in the 8:30 to 9 time slot more often than she arrives in the 9 to 9:30 time slot. That we know because she could arrive at any moment on any given hour in any given day. So if option 1 were true, then Karen should be going to the beach as many times as she's going to the museum. So if the first scenario were true, then she would be going 15 times to the museum and 15 times to the beach. And there's no reason why the two numbers should be very different. First explanation does not tell us why she's going 25 times to the beach and only 5 times to the museum. Now let's consider the second scenario that's given to us. Suppose train B arrives on the hour. So let's assume it arrives at 9 a.m. Then according to the second explanation, train A must arrive 10 minutes after that. So train A arrives at 9:10 a.m. So if you look at the previous hour, train B should have arrived at 8 a.m. So train A arrived at 8:10 a.m. So let's consider 1 hour in that time frame. So let's consider 8:10 a.m. to 9:10 a.m. It's a 1 hour time slot. Now suppose Karen arrives between 8:10 and 9. And that is a 50-minute time slot. If she arrives between 8:10 and 9, the first train that is going to come by is train B, and that takes her to the beach. Now remember that Karen's arrival time is random, so it's possible that she could arrive between 9 and 9:10. If that is the case, 9 o'clock, train B has left, so the only train that comes next is train A. So if she arrives between 9 and 9:10, which is a 10-minute time slot, then she is going to catch train A that'll take her to the museum. Now let's look at these two time slots. Remember that Karen's arrival time is random. She could come any time between 8:10 and 9:10. But if I ask you, is she more likely to arrive between 8:10 and 9, which is a 50-minute time slot, or is she more likely to arrive between 9 and 9:10, which is a 10-minute time slot? I'm sure you're going to say it is the 50-minute time slot because that time slot is larger than the 10-minute time slot. So this is more likely to happen. Her arrival from 8:10 to 9 is more likely than her arrival from 9 to 9:10 because of the size of this time slot. So she's 5 times more likely to arrive in this 50-minute time slot as compared to the 10-minute time slot. So if she is more likely to arrive in the 50-minute time slot, then obviously she's more likely to go to the beach than she is likely to go to the museum. So this explanation favors what really happens because she goes 25 times to the beach and only 5 times to the museum. So she's 5 times more likely, because 5 times 5 is 25, she's 5 times more likely to go to the beach than she is likely to go to the museum. So it looks like option 2 provides the explanation as to why she's going 25 times to the beach versus 5 times to the museum. So option 2 gives us the correct explanation. However, you can go over the next option, which is very similar to the one that we just went over. In the third option, train A arrives at 9 a.m. and train B arrives 10 minutes later. Now, if you think about her arrival time, if she arrives between 8:10 and 9, which is a 50-minute time slot, she catches train A and goes to the museum. If she arrives between 9 and 9:10, which is only a 10-minute time slot, then she catches train B and goes to the beach. So she is more likely to arrive in the larger time slot than she is likely to arrive in the smaller time slot. And if you think about it more specifically, she's 5 times more likely to arrive 8:10 to 9, which is a 50-minute time slot, than she is likely to arrive 9 to 9:10, which is only a 10-minute time slot, which kind of tells us that in this scenario, she's more likely to go to the museum, 5 times more likely to go to the museum than she is likely to go to the beach. So this explanation does not explain why she's going 25 times to the beach and only 5 times to the museum. So option 3 is not a correct explanation.